Hello everyone, this is Siddiqur Rahman and welcome to the fifth continuation of fifth lecture of the second week. So let's begin. By the end of this lecture, you guys will be able to convert hexadecimal number into the binary number. So let's move into the next slide. This slide represents the overall scenario of this lecture, and you may learn how to convert hexadecimal number into the equivalent binary number and some of the mathematical problems of this conversion using two types of method such as indirect method and direct method, and a table of this conversion and some of the examples for you guys to practice at your home. So let's move into the next slide. From this slide, you may learn the overview of the conversion hexadecimal to binary number. So let's start. Convert hexadecimal to binary is a conversion of a number in a hexadecimal number system to an equivalent number in the binary number system. The binary number system is a widely used number system. Its main application is its uses in computers. Computers can understand only binary language, so all other number systems give the user will be stored in binary form in computers. Thus the conversion of hexadecimal to binary is very important. So let's move into the next slide. This slide represents an example of the conversion, and this problem is solved by a method named indirect method. So let's start with the question: what is A to B 16, which is a hexadecimal number, and we need to convert it in binary. This problem splits into two parts, and in this slide we get the idea about the first part and we get the idea of the second part into the next slide. So let's start with the first part of the solution. First part and first step: convert the provided hexadecimal number into the equivalent decimal number. So let's start. The given hexadecimal number is A to B, and the base number of the hexadecimal number is 16. So we can write A to B 16 is equals to 16 to the power 2, 16 to the power 1, and 16 to the power 0, and A into 16 to the power 2 plus 2 into 16 to the power 1 plus B into 16 to the power 0, which gives us A into 256. We already know, or if you calculate 16 times 16, and you will get 256, and 16 to the power is equivalent to 16, so 2 into 16 plus B into 1, because 16 to the power 0 is equals to 1. So we get 10 into A is equals to yes, sorry, I repeat again, A is equals to 10, as we know, or as we discussed in the earlier slides. So I hope you guys don't have any problem to understand this. The A is equals to 10 into 256 plus 16 times 2 is equals to 32. B is equivalent to 11, which is 11 into 1. So we get 2560 plus 32 plus 11, which gives you, and finally we get 2603, which is the equivalent decimal number of the given hexadecimal number. So let's move into the next slide and the next part of this problem solution. So let's move into the next slide. And this slide represents the second part of the previous problem, or you can say the example 1. So let's start with the second part and second step. We need to convert the founded decimal number into the equivalent hexadecimal number. For this conversion, we need to divide the founded decimal number by 2. Okay, so let's start with the solution. First line, 2603 is divided by 2, and we will get 1301, and with a remainder of 1. And in this way we divide until the quotient part is 0, and then the equivalent binary number will be 101000101011, and that's the solution of this problem. So let's move into the next slide. So this slide represents a conversion table in between hexadecimal number into the equivalent binary number. So if you choose a hexadecimal number from the table like 6, and the equivalent binary number of this 6 hexadecimal number is 0110, and if we choose another hexadecimal number from the table, say D, capital D, or D, alphabet D actually, and if you convert this hexadecimal number into binary number, then you will get 1101. So let's move into the next slide. And from this slide we may learn another example about the conversion, which I meant hexadecimal to binary conversion, and this time we use to solve this problem direct method. So let's start with the question. Example number 2. What is 9AF base 16 in binary? As we already know, the base number of the hexadecimal number is 16. So start with the solution. First, we need to convert the provided hexadecimal number into the equivalent binary number. So if we convert, or if we see from the previous slide, or what I meant in previous slide, we saw a conversion table which is hexadecimal number in the sorry, I repeat again. From the previous slide we saw a conversion table which is in between hexadecimal to binary number. So if we convert 9 into binary number, then we will get 1001. The equivalent binary number of the hexadecimal A is 1010, and the equivalent binary number of the hexadecimal F is 1111, and this is the equivalent, and this is the equivalent binary number of the given hexadecimal number. So let's move into the next slide. This slide represents some of the examples for you guys to practice at your home by your own to understand the conversion of hexadecimal number into the binary number. So let's move into the next slide. In the next lecture, you guys will know what is binary codes and types, characteristics, advantage, and so on. So let's move into the next slide. And thanks for your attention, and that's all for this lecture. See you guys in the next lecture, and stay safe and stay at home. Thank you.